thing.
Awesome.
And yeah, you want to take it away, Ian?
Sure. Okay. Let me see how to present in this thing. Uh, where's my button?
Oh, it's
Um,
at the bottom in the center. There's a little up arrow.
oh, share screen. Cool. I'll do that. And it asks me about Safari. Yes. Awesome. All right. Can people see my screen?
Yeah.
Okay, cool. So I was trying to find the Jira that was mentioning this, which I found one. But I think what's in 2250, 2652. Oh no, I'm sorry, that's not that one. Okay, that one had the context of, so back in old days at Twitter, when we were like designing the best effort class, quality service class for revocable resources, we kind of used the different mechanisms to implement the lowest tier for best effort. And then we kind of went back and forth in choosing the scheduling policy versus a very low CPU shares. But that was the context, which I wouldn't go into the depth for. And then the second link is the design doc that describes the revocable resources design that was added by, I think, in a collaboration between Mesos and Twitter. We already have that today. Now, so the scope of this work is hoping to extend a little bit further, but focus on the CPUs first. Now, let me describe. I think everyone who are attending this meeting right now has a pretty good grasp on how we use CPU C group to isolated CPU time, but I'll just give a very quick overview. So by default, we're using CPU shares to guarantee the amount of CPU runtime allocated to each container. That's the default behavior. Now, Mesos agent currently provides a flag that flips CPU limits using the CFS quota for all of the containers. So if the flag is true, then there's no bursting allowed for all of the containers. And if the flag is not set, then all of the containers can burst past the guarantee and use the idle CPU runtime. And that's not very flexible because in our use case right now, we actually want one kind of workflow to be limited and the other to not be limited. And I would like to think of this as, so I think for the longest time, we were kind of rationalize the behavior from a services-centric point of view, which is if you're just, because you have as a user or as the application owner, you would like to model the amount of CPU that's allocated to each instance so that an aggregate, you want to say, okay, I have 100 instances. That will be sufficient for me to host, I don't know how many overall requests per second or the bandwidth or so forth. And you have to justify that 100 instance. So if each instance performance is somewhat predictable, then you'll be able to base the calculation on that. But if each instance capability kind of varies depending on how many neighbors they each have, then it becomes very unpredictable. So from this, and Mesos has traditionally been used primarily for services. So from that kind of perspective, it kind of makes sense. But as we try to utilize Mesos for a multi-tenant environment that accommodates both services and like batch type workloads, then because for batch, it's really a greedy kind of algorithm that you would prefer to give as much CPU runtime to batch tasks as possible. So different tasks would have different preference in this case. So then the CPU as the most obvious compressible kind of resource, now you naturally would think, okay, how can we enable both and have tasks opt in for one quality of service class versus another. So this is the proposal. Because utilizing CPU shares and CF's quota, we can already achieve that. So it's more of a API design thing at this point, I think, than a containerization thing, because the mechanisms are already there. So let me use the terms from Kubernetes to describe what we wanted to model. So basically, in Kubernetes, you have three classes of QoS. You have the guaranteed QoS class, for which the guarantee is the limit. So that is basically our behavior when the CFS quota is enabled. And the second class is burstable, which is our behavior for when the flag is not enabled. But you can within Kubernetes, you can define that per pod. And Kubernetes also defines a third class, which is best effort. And we actually have best effort with revocable resources already. And Kubernetes defines it in such a way that it's the QoS class is kind of inferred from the resource request versus limit concept in their resource specification, because unlike Mesos, so Kubernetes, for each kind of resource, you can specify the request, which if accepted will be your guarantee. And you will have the limit, which is in another dimension that limits, that caps the resources you can get. So is the basic concept clear here?
Yeah, I think so.
Yeah, I can move over to the API proposal, which then obviously there are like two options to take. One is to model it the same way that Kubernetes models it, which is give a resource guarantee and a resource limit. And the difficulty here is that I think with the Kubernetes, it's pretty simple. The resources are basically just numbers. And our resource types have a pretty rich set of metadata in there. And there's role, and there's type, and there's allocation versus reservation. So if you look at this proposed additional fields there, I can sort of come up with like problems that I can see that potentially can arise, which is the question of how do you like provide another field that specifies the resources, but make it obvious that you should put only quantities in there, or you should put only the limits there, or you should, for example, I have my guarantees for CPU, memory, and disk, and I only want to set limits for my CPU. And how do you express that? Should you like set all three, but have resources equal limits for memory and disk, and only have different numbers for CPU? How do you do that? And another insight that I got from Kubernetes is that in their design doc, they kind of already kind of admitted that the rule that they set up to infer the QoS class from the resource requests and limits are pretty subtle. So basically, guaranteed then means all of the resources will have matching requests and limits. And if it doesn't match that, so Gilbert was asking if the doc can be shared with us. Yeah, I'll publish it after the sync.
Yeah, sorry to interrupt. Thanks.
That's fine. So yeah, and then if it doesn't qualify that, but you also have requests, then you're in the second category, which is burstable. And if you don't qualify that, then that means you're not setting requests. Then you're in the third category, which is best effort. So the rules are not that straightforward. But in addition to that, Kubernetes has this behavior of burstable for incompressible resources. In this case, right now, only memory supported. They actually kill pods that are in the burstable QoS class if the pod's using more resources than the guarantee. So that, at least to me, doesn't feel like the model that Mesos has here, because we have that defined for the revocable resources. So if you're using revocable resources, you should be prepared to be killed. And as I will mention later, maybe there's another kind of killing which is be preempted, but that's kind of a orthogonal feature. At least when preemption is not happening, Mesos will, under current circumstances, wouldn't kill you. And I think if I were to design something that's burstable, I think my preference will be that I don't want, so if my batch jobs utilizes more resources than its minimum guarantee, I don't want it to be killed. So that's how I think about the Kubernetes behavior. And the second option is, okay, how about we just define the QoS class explicitly? Then in this world, you will have a QoS class, guaranteed, burstable, and potentially also best effort within the task info. And you specify the class you want your task to be associated with. So that is the intent. And the intent is very direct, in my opinion. And also, that's just the intent. It doesn't mean that you will always get a guaranteed or burstable behavior. well, guarantee is sort of you're certain because that's the basic Mesos guarantee. But burstable, depending on your resources, you may not be able to burstable, but that's your intent anyways. So I think this kind of API allows you to use just one field to explicitly set your intent. So actually, so the second option is what I'm preferring here. I'd like to select feedback, if not right here, yeah, maybe at least later when I publish the doc. So a little bit concerned maybe is that, okay, right now we're just gonna do CPU. So, but I think this is still okay. For my task, I'm saying it's okay if the resources that's given to my container bursts past the guarantee. I'm just saying it's okay. But however you're dealing with it, I mean, whether or not it actually bursts past the guarantee, either is fine. So, yeah, I think given the time constraint, I'll just leave it at that for this part of the API. And just one thing that that occurred to me, that so with the priority tiers design, we're gonna then model, okay, when is it possible for a task that's supposedly in the guaranteed QoS class to be preempted? And my understanding is that these two actually don't conflict. So one is how my tasks rank against others, and the other is whether I'm willing to burst past the limit. So so a wrinkle here is that, okay, so we already use revocable resources to denote the best effort QoS class without explicitly specifying it. Should we kind of refactor that and pull it into the QoS class and just try to, you know, chart the path towards making that explicit? So yeah, that's the a summary. I kind of wanted to get a sense of how people think of this feature overall, and the direction in choosing between the two alternatives, and more, and if people like have something else in mind, and then I will certainly extend this doc and to think about all of the edge cases and implementation and transition stories, all of that.
So one thing that comes to mind is that I think when we're comparing to Kubernetes and their implementation, so I don't know about this side of Kubernetes too much, but I think that one additional dimension we have in Mesos is the configuration of the isolators on a particular agent. So I think the behavior that the user observes will depend on the isolators that have been loaded on that agent, right?
Sure.
So in the case, you mentioned the memory case. So isn't it true that in the memory case, if the cgroup's memory isolator is loaded, then the resources defined in the task are both a guarantee and a limit, right?
You mean in a Mesos world?
Yeah.
Yeah, I think it's both the limit, both the guarantee and the limit, yes.
And then if the cgroup's memory isolator were not loaded on that agent, it would be just a guarantee, maybe?
Is it possible to not? Maybe it's possible, yeah. But in that world, I think it will mean the memory is not isolated. So no matter what you set, everybody is just contending for memory resources, and the kernel would have to, in its, for example, in its ooming logic, in its reclamation logic, would have to treat these processes as if they were just normal system processes.
Yeah, so I guess that's, to me, from the API perspective, one thing that's interesting there is that the API that we're considering here in the document doesn't completely specify the behavior that will be observed. It's kind of a combination of this and the isolators loaded on the particular.
So you're saying that. So right now, I think when you're using resources, well, it's not written down. I don't think I see it, but I guess people on this call can probably provide a opinion. I think the current semantics is really that, okay, it's guaranteed because it's allocated to you, it's offered to you, and you choose to use it. So it's a guarantee. But the fact that different agents could have different isolator configuration is a fact of, okay, that's my promise, but how much I can fulfill that promise, how strict or lenient I want to be for that promise, then is up to the operator to configure. So I don't think that changes the semantics in the API in terms of my task info specifies 1 gig of RAM. I think it still means I should be guaranteed the 1 gig of RAM. I guess your point, I take your point that, okay, that was somewhat implicit. And now if I choose a guaranteed policy, QS class, and I don't have an isolator to do that, then it kind of is not guaranteed, right? I guess that's what you...
Yeah, exactly. I think it's maybe more just something that we would consider in the comments and documentation. We would want to make it clear that if you're explicitly limiting something, that will work as long as you have appropriate isolation installed.
Yeah, I feel like it's more like moving from a per agent configuration for limits toward a per task configuration, and the agent and isolator need to respect those configurations from the task info. And if the agent cannot fulfill that, it should like fail the task or reject the task.
Yeah. Huh.
Right. So yeah, I think yeah, I would agree that. So like for a operator's guide, you should probably say that if in this cluster, these types of resources are configured, you should isolate them. If you don't, then the Mesos semantics are not guaranteed, and that is, you do that at your own peril. So, right. So that doesn't change how Mesos is supposed to work, right?
Well, I think Chunhung is, if I'm correct, Chunhung's suggesting that we could have the agent actually fail. For example, a task that attempts to explicitly limit memory if a suitable memory isolator is not installed on the agent. I think that's an interesting idea. We would have to have some way, like either we would just have some hard-coded set of isolators that work for a particular purpose, or an isolator could like advertise what limits it provides in a systematic way.
I imagine that we could probably pass the task info or like some metadata that relate to these constraints to the isolators, and that isolator decide whether like it can be fulfilled or not. Well, yeah, I haven't think about details yet, but it seems to me that, well, if we can declare that these like QoS classes have these behaviors, and if the agent cannot fulfill these behaviors, it should fail the tasks and tell the user that, oh, this cannot be, it's not doable.
Yeah, I think that's possible. I wonder if most people would want that, because, okay, so if it's not a guarantee, then I may run things there and fail later. Yeah, I guess they would want that. So if they fail early, they can reschedule. If they fail only when the guarantee is not matched, it may be a like unfortunate timing or something. I can see the point there, but so also I've been hearing conversations about, okay, so maybe agents should provide their isolation to the scheduler, so that the scheduler would know what kind of isolation is on this host and choose buffers accordingly. I don't think there's anyone who proposed anything in more detail, but I think that would solve it in a reverse way, right?
So you're saying the offer would include isolation information?
Yeah, a variation of that. If not for like the list of isolator names, at least maybe there are some capabilities and so forth provided there. Yeah, I can think of the cases where that will be useful, but I think it's a little bit orthogonal to this proposal here, because right now, as a user, I really think this is, when I specify the resources in the task info, it's really something I think the cluster is supposedly gonna guarantee for me. If not, so for example, before the ports isolator that James recently did, I mean, I can claim this port and somebody else could just use it, and I will fail. But you see what I'm saying? So that will solve the issues that isolate tasks better. But is it really tied to the QoS class? Because in the end, as I was trying to clarify there, so this is the intent.
Yeah, I think maybe the main difference for me is that adding something like this to the API would make the limiting explicit. So it seems a little more significant if the agent couldn't satisfy it. I could imagine us implementing it either way, either just leaving it up to the operator to configure the agents appropriately, or having logic which will fail tasks that an agent can't limit appropriately. And I'm not sure immediately which seems more suitable to me, but it seems like a high-level question that is worth considering, perhaps.
Yeah, I think I can incorporate that in the design doc in a more thorough version, and solicit more feedback from the dev list.
So the resource, for the purposes of resource arithmetic, everything that's get represented there is guaranteed. Is that right?
You're can you reiterate that? The arithmetics is
So
guaranteed.
when the scheduler is dealing with resource arithmetic and it's asking for some amount of CPU,
Right.
that CPU is always a guarantee. Is that correct?
That's my interpretation, and that's how I was framing the previous discussion.
Yeah.
So I think it's always been like that.
And it may also be a limit depending on the isolator configuration.
No.
No?
So if in the model as a generic QoS class proposal, my understanding is that the resource arithmetic is always a limit, but if you if you ask for burstable QoS, you may be able to exceed that. So it's always a limit equals guarantee, but
No, it's always a
you
guarantee.
ask for, so it's always So it's always the guarantee, but if you specify a burstable QoS, then you implicitly get limit equals infinity as well.
Yeah, potentially, yeah. And you're just saying that you're okay with that.
I'm okay with that. I just wanted to clarify.
No, I, not you, but the owner of the task is okay with being allocated more resources than in the task info. Because I was just describing the case where the task owner is saying it's not okay. Because I want to model my CPU or other resource consumption more precisely. So I would rather, if I want my distributed application to serve more traffic, I would rather increase my instance count from 100 to 200 than unpredictably have like more CPUs per instance. That's the case I'm describing, that the user saying it's not okay.
Oh, so sorry. So when you say using different QoS classes, we may want to allocate resource based on different classes. Like for guaranteed, we allocate the task for what they like. So I kind of got a little lost. You mean like say for burstable or for what? Which one? Like for burstable, where the limit is larger than guarantee, you should allocate the allocated with the limit rather than guarantee. I don't get
right. So take CPU as an example. So if I have launched a task onto this agent with 32 cores, and I specified CPU equals 1, if guarantee in a guaranteed class, I will only use 1 core, even though there are the other 31 cores that are totally idle. But perhaps I want that. So that's the guaranteed semantics. And that's actually what the flag, the original agent flag provides, that semantics, and Twitter uses it.
And what does the best effort value indicate?
So the best effort will, in our world, be equivalent to revocable resources. So, and it's not 100% clear to me how we want to reconcile the two or consolidate the two. Should we have the enon here and translate revocable resources to this enon? So after that, you will be able to refer to the type QoS class, or should we not have best effort here and solely use revocable resources? But that would be equivalent of using revocable resources.
Okay.
So I have a question, like from the allocator's perspective. Should we allocate resource based on the guarantee or the limit?
So the guarantee. So that's what James was trying
Yeah,
to clarify.
that's what that's what I understand. But we also mentioned about like you want to precisely control the limit. How do you do?
Yes.
Like I don't like how do
So-
you do that?
So if you choose QoS class guaranteed, then your resource limits equal your resource guarantee.
I got that, but for the other classes, like first of all,
Then
yeah.
then it's burstable. Then so there's no limit.
So
You
you're
have-
proposing burstable implies limit equals infinity.
See.
Yes.
So there's no API such that I want to set a guarantee and a upper limit. So we don't support that.
That will be option one, but
Okay.
I'm not seeing a case where users would actually want that.
Got it.
So yeah, I can see potentially. So that's probably the design rationale that Kubernetes had when they, chose the path of having explicit limits versus requests, and infer the QoS class from there.
I mean, it would also be possible to specify a finite limit with your proposal number 2, right? They don't seem mutually exclusive to me.
Probably, but the challenges, as I was alluding to when I was describing, I kind of glossed over option one. But what do you put there? Like I was saying, the resources in our world is a class with tons of metadata. Should you just use quantity there? What should you use there? It's
Well, there's probably only going to be a certain category of resources that are able to burst.
yeah.
Like you wouldn't be able to burst with a volume, for example, which has metadata.
Yeah, but then do you validate in terms of, okay, disallowing other kind of resources, or do you just, okay, so let's say if there's only CPU, right, then should you put the same amount of metadata in there as the resources fields?
I could imagine a couple options. I could imagine having users specify the entire resource or just specify the value message, which might contain like a scalar in the case of CPUs to specify the limit.
Mm-hmm.
Yeah, I mean, this is pretty low-level details. I think we could figure something out there if we were going to go with that approach. I think in the past when people have proposed QoS classes, what was unfortunate was that it's a bit of a high-level API. It's kind of constraining what you can do. Like you couldn't say, I'm going to launch a Spark job and I'll give it a core, but like, please, if there's free cores in the box, like, let me just consume all of them. Like that's possible with the Kubernetes API, but it's not possible with QoS classes unless you introduce some kind of, or maybe that's what you have as burstable, I'm not sure. Like, I guess you have the category that you can burst up to something with no limit, but it just doesn't have the category where there's like I can burst, but up to a finite amount. Is that the limitation of that approach?
Yes, it is. And I just...
Yeah, I think
I
the other
wonder
thing
there's a concrete case for me to actually want to burst, but only to an extent.
Yeah, I haven't heard that either yet. I don't know what the use cases are. There might be some, but I don't know. But I think the other thing that's the hard part of this API is how do we integrate this into resource management at the cluster level? Like, should I be able to constrain the total amount that Spark can use, even including what it's bursting with? Which you can do in Kubernetes. You can say, okay, Kubernetes limits are limited to a total of, or like Spark is limited to a total limit of like 100 CPUs, which means the sum of all of its limits can't be bigger than 100. It's like the maximum amount of CPU you could possibly use is, you could say at the cluster level, not bigger than 100.
Yeah, we could do that, but then again, I'm not seeing how useful that will be.
Well, I don't know. I mean, I might want to say that if I'm charging based on consumption, or if they're paying ahead of time for how much they can consume. If I have a model where I charge them based on what they use after the fact, should be fine, right? Because they used a lot of CPUs, they get charged, and they pay for it, right? If I'm upfront saying, okay, well, you guys have paid to get like access to 100 cores, 50 of those are like bursted, so they're cheaper, but I'm not going to let you go over 100 right now because you've only paid for that amount.
But
then it
also,
doesn't pan
in
out.
that model, you're probably thinking about charging based on actual utilization. So the limits itself doesn't say whether you're actually using it. So
right, but it might.
You're not reserving it either. So it's not like the reserved instance that nobody else can use. It's like
AWS. It's like AWS, where like I've actually, even though I don't really tell you there is a limit up front, you can contact AWS to get that increased, but they're putting some guardrails in up front to try to stop you from going crazy.
The feature Ben's describing sounds to me like a customer-friendly kind of thing. So I want a burst, but I also don't want an unexpectedly large bill at the end of the month. So I'll burst.
Right.
I want to be able to specify a maximum limit.
It's like self-managed limiting versus the operator enforcing that limiting to try to make sure that they don't get a bad bill.
Yeah, the operator, I mean, I guess from an operator point of view, if the burst will only burst if nothing else has that CPU guaranteed to it. So I struggle to care, but from a chargeback point of view, then you want to have some predictability in what your bill's going to be.
Right.
Thinking about Mesos quota, like setting a quota limit, I could imagine having like a two-tiered limit where you can limit the guaranteed resources for a particular role and also limit the total usage. Is that something that you guys have considered at all in the quota work, Ben?
Yeah, I mean, if you look at how to map it back to Kubernetes, what their quota is just limits. You can set a limit on the requests of the pods, and you can set a limit on the limits of the pods. The first thing is basically, what's the limit on the amount of guaranteed CPUs you're going to get in the cluster? And the second thing is, what's the limit on the total amount of CPUs you could consume in the cluster? So it's like a two-tiered quota based on the guarantees and the limits of a pod. Ours is a little more complicated because we have guarantee and limit just for the guarantee of the pods. And then in theory, we could have maybe just limit for the bursting of the pods if we wanted to enforce that they don't consume more than a certain amount globally.
At a role level, the limit on bursting seems difficult to implement. Doesn't that imply some like real-time update of resource usage?
No.
No?
No, you just sum all of the limits of the pods or the tasks together, the executors together. and that shouldn't exceed a limit.
Well, what if we're not talking about finite limits? Like if the limit is infinite for burstable tasks?
Well, we know what the effective limit is from the box size.
So you would just treat the finite limit as all of the unallocated CPUs, for example, on a node?
You'd probably treat it as the node size. Yeah, effectively, roughly what you said. Like I think that's what Kubernetes is probably doing, if we looked at how they implemented it.
Okay.
That's my guess.
Right. So I've been thinking about Ben's and James's points on the bill. Then in that case, wouldn't guarantees be what you'd be concerned about? So because ultimately, depending on the chargeback model, right? So if you want to limit your bill, then can't you just choose the guaranteed mode?
Well, those are more expensive, right?
Okay,
like
so
I might just want to run a job that just takes whatever's free because it's cheaper. But because I'm not smart enough to like self-limit my job, it goes really wide and takes a ton of resources.
Okay, I think about it.
So one of the things, one of the ways we use the burstable CPU at the moment is as a somewhat as a approximation to autoscaling. And you can think of it like that, as a restricted form of autoscaling. So you deploy something which is idle most of the time, but then has, lunchtime traffic or breakfast traffic or whatever you have. And in the absence of any sort of autoscaling controller, burstable CPU does a job, right?
Yeah, so you're saying it's like auto scaling across the instances where if there's free resources on the box, the particular instance can scale up a bit.
Exactly. It's
vertically.
It's restricted auto scaling, which
yeah,
implement.
That's actually interesting because I've mostly seen this feature be used for non-services, for batch workloads, because what I've usually seen is the services want predictability. So if it were the case that those boxes that they happen to be on were full, they wouldn't be able to auto scale at all, and they would actually need to do something.
Yeah, I think there's classes of, at least from around here, there's classes of service, because there's customer-facing production services, and then there's random migrate web service thing that teams use it internally. So the auto scaling behavior makes more sense for the latter class than for the former class, I think.
Got it. Okay. So that sounds like a case of you want a minimum, you want to go up to some potentially unlimited amount, and you don't necessarily want to limit the ceiling of it.
I mean, I think we could limit, for this case, we could limit the ceiling for it, but it's not really very obvious how we would limit the ceiling.
Okay.
The chargeback case is really the only one that I've thought of that sounds plausible for the limits.
Okay.
I do like the simplicity of the model as a generic QoS class. It feels like you're basically bumping the existing Mesos flag up a layer from the agent, from agent to task, and that feels pretty simple and pretty understandable and fits in. I can see a clear path to getting that work done and deployed.
Yeah, my initial impression is also that the explicit approach is nicer.
Explicit
Which one's explicit?
The generic QoS class option.
Okay.
I think that boils down to I think in practice it boils down to a flag. Like modeling as a generic QoS class, it feels a little bit like an over abstraction or over promise, but it's basically hoisting in practice it feels like it's hoisting the flag up from the agent.
Yep. So from what I've gathered, the two options are actually not mutually exclusive. But if it's first model, that's probably where more discussions, we can extend from the option 2 to include option 1. But I imagine it's at that point, we probably need to plug that into the whole cluster-wide quota and allocation algorithm, arithmetics.
Yeah, I think
do more things.
I think for the first approach, there's probably some refinement needed as well. Like maybe what we put in is specifically like CPU limit and memory limit, things that we know can have an amount that's larger. Like we wouldn't care, like there's no port limits, there's no like volume limits, right? So we might actually want to start with a restricted model there if we were to go with that approach, rather than trying to make it really generic and just taking resources as limits.
And I think in either approach, we want to consider how the quota system should handle bursting.
Yeah.
Yeah, I mean,
it would be.
Make sense. Sorry, Ben.
No, it's okay. Go ahead.
I was just going to say, can limits make sense for anything except CPU? I can imagine maybe if you network bandwidth, you could burst in some way. But
that's what I'm not sure about. I feel like it's very isolation dependent, and we kind of have a sense of which things would make sense for bursting for now. At least like we could try to scope it down.
It's also probably platform dependent, like because if you're like explicitly asking for a different limits versus guarantees, then whether a particular platform can do that.
Yeah. Also how you set up the isolators and everything. I guess that would be nice to validate ideally. But what I was going to say to Greg's point was, it would be nice to. I do agree. It would be nice to keep in mind that at some point we're probably going to want to be able to have an operator control on how much total consumption something could have, at least for the billing use case you talked about, possibly for some other reasons. And that's the one piece of the QoS one that I'm a little less clear on how that would work. And I guess the other thing that probably isn't clear to people, including myself, is, and Ian mentioned this, the interaction with revocable resources. Like I didn't actually think that best effort was revocable because we're not going to destroy the container, I assume. It's like there's different kinds of revocation, I guess. There's like a temporary kind for like CPU, and for disk, what can we do, right? We would probably have to like kill the container. Or if we were doing revocation, like I'm using Ian's reservation, when I revoke those resources, I probably have to kill the container because I'm using someone's reservation or something like that. I guess it depends, but it seems rather complex, I guess. I don't know how those two things are going to interact.
Right. So I think we went through a lot of these things when we designed the revocable resources, and think at least right now the well understood semantics is that if you use revocable resources, you should be prepared to be killed. And whether or not you're actually killed, at least that's the semantics, you should be prepared to be killed.
The oversubscription stuff?
Yeah, oversubscription.
Oh, okay.
Oh, yeah, sure. If not for another kind of, no, but revocable really just means it could be revoked, right? When it's revoked, are you?
But this isn't also setting the revocable flag, is it?
This is not. So I get your point. So maybe, so what I was trying to say is I think currently revocable already implies best effort, but probably best effort wouldn't necessarily imply revocable. So we could probably allow that as well.
Yeah, I mean, we probably just want to think holistically about what revocable should mean, keeping in mind that it's not just oversubscription that kind of relates to revocable resources.
Unused quota, yeah.
But I do like the idea of kind of focusing on this first, because this is something we badly needed for a long time. Just the ability to have per container bursting, local bursting. When we add, I guess, what do we call that? Like global revocable resources. Like let me just take a step back. I think for things like Spark, it's pretty useful just to be able to say, I'm going to run a bunch of containers with like maybe one CPU or like half a CPU or something, and just they're burstable. And that I think is already pretty useful, even without having the ability to say like, okay, all the quota's been given out and I want to run Spark on these totally preemptible resources where like I'm not getting any quota guarantee at all. That seems like also potentially useful, but I don't think it's really as necessary as building this. I don't know. Now I'm just rambling, but
no, so yeah, that's the bottom of the doc, right? So I think it will have to interact with the preemptibility, but
yeah, I'll try to do some thinking as well, just to try to figure out how these two things would interact, and see if I can figure that out.
Awesome.
Cool. Well, we're out of time. That was a really good discussion. Thanks, Ian, for presenting. That's awesome. Does anybody have any last comments before we break?
So I have something not about this, but the next item on the agenda. I don't have any time to discuss it now, but I sent an email about the first item yesterday about Scalar library interface changes, and I would welcome any feedback there.
So yeah, my thinking around this is that we have these useful work groups, but it probably doesn't prevent us from schedule ad hoc discussions, right? So
yeah, certainly. Yeah, I apologize, Gaston, that we did not get a chance to cover those items. You can see Gaston's emails, and I also included a link in the agenda to a particular review that I thought might be of interest, where we introduce some new operation states that will be used for reconciliation.
Mm-hmm. Yeah, there was another email about that as well.
Yeah. So feel free to reach out to Gaston or myself about that work. We can chat on Slack or have a hangout.
Yeah, awesome. I definitely will spend some time this week.
Cool. Thanks for attending, everybody. Really appreciate the discussion today. Next, and Ian, if you could please share that doc on the mailing list or on Slack, we can continue our discussion there.
Yeah, I'll do that. It maybe not today, but I will do that ASAP.
Okay, sounds good.
Yeah.
And yeah, I'll see you guys in 2 weeks for the next meeting. Nice seeing everybody. Take care.
Yeah, take care.